We present VisCut, a system to efficiently render dynamic hierarchical virtual environments. The system uses hardware occlusion culling to achieve high performance. Occlusion queries return the number of pixels drawn when an object is rendered by the graphics pipeline. To efficiently render large models, the VisCut system optimizes the traversal of the hierarchy and the number of issued occlusion queries at runtime. The visibility cut method is a lot faster than existing state-of-the-art in dynamic occlusion culling. In the same amount of time on the same model, VisCut ends up rendering far larger number of frames than coherent hierarchical culling as seen in this video sequence. Since CHC starts at the root of the object tree every frame, it performs poorly in cases when large sections of the world are in view. The VisCut system performs faster than CHC even in high occlusion environments such as the city model discussed in our paper. Our system provides support for multiple dynamic entities without any slowdown. In this sequence, each of the 4096 ellipsoids move randomly in the environment. For a typical occlusion culling system, this is a very hard challenge. However, VisCut manages to render this dynamic scene at the same performance level as the static scene. As seen in this graph, the hit on performance due to dynamism is really insignificant. The VisCut system provides explicit support for transparent objects. In our system, the only performance penalty involved is that associated with sorting of transparent objects in back-to-front order for correct rendering. As seen in these graphs, this is only limited by the host CPU and not very significant on modern systems. For improved performance, our system supports an LOD scheme based upon the number of pixels returned by occlusion queries. A pixel-based LOD scheme performs much better than a distance-based scheme, especially when there are a large number of small occluders on screen, as seen in this sequence. We presented the concept, design, and implementation of an occlusion culling system based upon visibility cuts of an object hierarchy. A system performs better than any existing occlusion culling scheme for dynamic environments. A system such as this would find wide use in large model visualization, computer games, and other 3D rendering applications with hierarchical models. We conclude by presenting a few clips of our system rendering a few other extremely large models.